the ions are going to go. There's a shorthand notation that I'd like you to learn. Obviously, we don't want to draw those big, huge pictures every time. So what you do for this cell, you would draw. I'll draw you the notation, and then I'll show you what it means. Okay. So zinc to zinc ion with a line in between, and then a double line, and then copper ion and copper. Okay. So the format of this is you write over here what's happening at the anode. Okay, which we remember is the oxidation, right? Okay, and over here you write what's happening at the cathode, which we remember is the reduction. And this double line represents the salt bridge. Okay, so this is a shorthand notation for this reaction. Zinc plus copper ion gives you zinc ion plus copper. And if you're thinking you're going to forget which is which, it's alphabetical. Anode, then cathode. That might help. It might not. I don't know. So let's just take a look at a copper-silver reaction. Okay. So it's telling us over here that this is the anode. So what's happening at the anode? Well, we said the anode is always the oxidation. So we know at this section, the copper is being turned into copper 2 plus 2 electrons. Okay, so remember anodes are negative, so we have a negative electrode here. Goes up through, we can measure voltmeter, we're going to learn what that is in a video or two. Comes back here down to the positive cathode, okay, where those electrons are now going to react with some silver ion from solution, okay, to make some silver metal. Okay, and again we've got a salt bridge. Okay, and just remember the cations always move towards the cathode, and the anodes move towards the anode. And if we were to write this overall reaction, right, it would be copper plus silver ion, 2 of them actually, gives me 2 silvers plus copper 2 plus. Okay, and if we wanted to do that in a shorthand notation, again on the left you write the anode. So you would write copper going to copper ion. We write our salt bridge. Okay, and then we write silver going to silver ion going to silver. And note that we don't put the balancing part in there. Okay. Now, sometimes you're going to run into situations where you can't use the metal. Okay, so for instance, what if I took some zinc solid and I reacted it with cobalt 3 plus, and that turned into zinc ion and cobalt 2 plus. Well, I can use a zinc electrode. Okay, on one side I'll make my electrode out of zinc, but in the case of cobalt, I don't have cobalt, I have 2 different cobalt ions. So whenever you don't have a metal available, you're going to use an inert electrode. Okay, that means some metal where you can react on the surface of it, but it doesn't actually react. Almost always going to use platinum. Okay, so since we've just been showing you pictures, let's see if we can draw this one kind of from scratch. So I'm going to kind of draw a beaker here. Okay, a beaker here. It doesn't matter which side I put the anode and the cathode. So I'm going to go ahead and make this side, let's go ahead and make this my zinc. So in solution here I would have zinc ion. Okay, and now on this side I have an electrode, but it's not the metal, it's made of platinum. So in the solution I would have both cobalt 3 plus ions and cobalt 2 plus ions. Okay, and over at my anode here, right, this is where the oxidation occurs. So I would have zinc turning into zinc ions plus 2 electrons. Remember, this is negative. So it's going to come up here through what we'll call a voltmeter and back into here. So the electrons are going this way. Okay, and again, I could have written this backwards. It doesn't matter. And they'll come over here and they'll react. And over here at the cathode, okay, this is where we have the reduction. So this is where we have cobalt 3 plus plus an electron, giving me cobalt 2 plus. Okay, and then I add them up and I get this overall reaction. Okay, and I'm not quite done because I've forgotten a piece, right? I have to, this is a solution, I have to go ahead and add my salt bridge. Okay, so you just kind of add that in here and show that the potassium ions are going this way and the nitrate ions are going this way, and that's your salt bridge. Okay, if you wanted to do a shorthand notation, you would do zinc to zinc ion. Here's your salt bridge, and now you say cobalt 3 plus and cobalt 2 plus, and then you put platinum as your electrode. Okay, so that's a little bit different, but not very different. When there's gases involved, okay, what if we have the reaction like 2M solid plus 2H plus gives me hydrogen gas plus 2M plus. Again, so M is just a metal, okay? So over here I'll have my metal anode, right? That's my anode because that's where the oxidation is taking place. Electrons are produced, they go through my voltmeter and they come in here. Now on this side, again, I have a little platinum electrode, and what happens is the reaction can take place on the surface of that electrode, and you'll see that the H plus ions react with the electrons and they make hydrogen gas, and the hydrogen gas kind of escapes out here. Alright, that's just giving you an idea like what would you do if gases were involved. And again, shorthand notation is M goes to M plus, salt bridge, H plus goes to H2, okay, platinum. Now this has been a little long, so let's just kind of summarize everything. Okay, a voltaic cell consists of two half cells joined by an external circuit through which the electrons move and a salt bridge through which the ions move, right? Each half reaction consists of an electrode dipped into an aqueous solution, so like zinc into zinc ion. If you have a metal in the reaction, you just use that as the electrode. Otherwise, you're using an inert electrode, usually platinum. Okay, in one half cell, you got the oxidation at the anode, reduction at the cathode, and the overall reaction is just the sum of those two. So we'll practice drawing some of these, and just this is all descriptive so far. When I show you the math part is actually really easy.